Assalamualaikum. My name is Nurul Kristina binti Nordin. My student ID is 2021119935 and I'm from A4CS2304B. I will be presenting to you my Java application. My application name is e-convenience store application. This application will use stack and queue which are extended from linked list. So, what is stack? Stack is a linear data structure that is used to store the collection of objects. It is based on last in, first out, LIFO. What is queue? Queue in Java is a linear ordered data structure that follows FIFO, first in, first out, ordering of elements. This means that the element inserted first in the queue will be the first element to be removed. In this application, there will be link class, node class, empty list exception class, stack class, queue class, e-store class, main store class, and expression conversion class. Let me show you each of these class code. First, we dive into node class. We have public class node object data, node next, and then we declare the default constructor, normal constructor, getter, and setter. We will have update data method. We write it like that. Next, we have update the reference to the next node method. We write it like that. We have a method to get the data and a method to get the next data. And lastly, we have a print method to print all the data. Next, we move on to empty list exception class. We write the code like this: public class empty list exception, extend runtime exception, public empty list exception, super, the list is empty. Next, we move on to link class. In link class, we will declare private node first, last, and current, and then we will write the default constructor, and then we write the method to check whether the link is empty. Next is the print method to print the data from the link list, and then we will write the method to insert the data at front of the list, and then we also have a method to return number of elements in the list. Public int size int count equals to 0. If is empty, return count. Current equals to first, while current not equals to null. Count plus plus, current equals to current dot next, return count. Next, we have method to insert the data at the back of the list. We write it like this. We also have a method to return first element in the linked list. Next, we have a method to return the next element in the linked list. We write it like this. This is the method to return the last element in the linked list. We write it like this. Next, we have a method to remove the first element in the linked list. Next, we have method to return last element in the linked list. We write it like this. Next, we move on to queue class. Q class, we write it like this: public class Q extend link, public Q super. To insert the data in Q, we insert it at back. We use NQ, and to remove it, we will remove at the front. We use DQ, and then we have get front method to get the first element in the queue, and then we have get end to get the last element in the queue, and then we have is empty method to check whether the list is empty, and then lastly we have the print method to print the queue data. Next, we move on to stack class. Stack class is also extends from linked list. We write public class stack extend link, public stack super. Push method is to insert the data at the front of the list, and pop is to remove at the front of the list. Pick is used to get the first element in the list. In stack class, there will also be the is empty method to check whether the list is empty, and also we have print method to print the data from the stack class. In expression conversion, there will be several rules to follow. The first rule is to print the operand as they arrive, operands such as A, B, C, 1, 2, 3. The second rule is if the stack is empty or contain left bracket on top of the stack, push the incoming operator onto the stack. The third rule is if incoming symbol is left bracket, push onto stack. The fourth rule is if incoming symbol is right bracket, pop the stack and print the operators until left bracket is found. Rules number 5, if incoming symbol has higher precedence than the top of the stack, push it onto stack. Rules number 6, if incoming symbol has lower precedence than the top of the stack, pop and print the top, then test the incoming operator against the new top of the stack. The seventh rules, if incoming symbol has equal precedence with the top of the stack, use associativity rules, which is left to right, pop and print the top of the stack, then push the incoming operator. If right to left, push the incoming operator. Rules number 8, at the end of the expression, pop and print all operators of the stack. This is how we write the expression conversion class. Class expression conversion, public string infix to postfix string s, stack character, stack equals to new stack character, string postfix equals to double quote, char equals to s dot to char array. For char, c equals to char if char not equals to plus, and char is not equals to minus, and char is not equal to multiply, and char is not equal to division, and char is not equal to left bracket, and char is not equals to right bracket, postfix equal to postfix plus c. Else if c equals left bracket, stack dot push c. Else if c equals right bracket while not stack is empty, char p equals stack dot pop. If p not equals to left bracket, postfix equals to postfix plus p. Else break. Else if c equals plus, or c equals minus, or c equals multiply, or c equals division. If stack dot is empty, stack dot push c. Else while not stack is empty, char m equals to stack dot pop. If m equals to left bracket, stack dot push m, break. Else if m equals plus, or m equals minus, or m equals multiply, or m equals division, if get priority m less than get priority c, stack dot push m, break. Else postfix equals to postfix plus m, stack dot push c. While not stack is empty, postfix equals to postfix plus stack dot pop, return postfix. Public int get priority char c. If c equals plus, or c equals minus, return 1, else return 2. Next, we move on to eStore class. In the eStore class, we will declare the name, ID, quantity, and price. And then we have the default constructor. We write it like this: the normal constructor, the setter, and the getter. And lastly, we have the print method to print the data of the eStore. Next, we move on to main store. For the main store, we will declare the queue, the new queue, and the new stack. We declare it like this: queue my queue equals to new queue, stack my stack equals to new stack. And then we have to declare the name, ID, output, quantity, and price. This is how we going to insert the data in the list. We write it like this. Next is the method to calculate the total price of all items and the average price of the all item. Next, we have a method to calculate the minimum and maximum price of all items. We write it like this. Next, we have search method for user to search item by the item's name. We write it like this. If the item were found, the application will display the item details. If not found, the item will say the item you searched is not found. And then we have a method to remove item which quantity more than 5 from the queue and store it in my queue many and my stack. We write it like this. This is the method to display information in queue which the item is more than 5. This is the method to display information of item in stack which are more than 5. This is the method to delete information in my stack 1. We write it like this, and we will display information in my stack 1. And then we ask user either to delete the data in stack or not. Lastly, we have the expression conversion method We ask user to input the infix expression, and the application will convert it into the postfix. This is the output of the application. That's all from me. Thank you for watching. Assalamualaikum.